where it starts out and a negative x here where it ends up, that's not going to make it flip over the horizontal. I'm sorry, flip over the y-axis. Only if it changes from here to here. Right? Since they're both negative x, that doesn't count as one of the transformations. The only things that's different from the red to the blue is this negative and this 1/8. Right? Okay, so what does this negative do? Reflects over x or y? Right? Okay, just like we've learned before. And what's the 1/8 do? Is it horizontal or vertical shrink? Vertical, right? Vertical shrink and stretch stays the same number, okay? And if it's a fraction, it's a shrink. If it's a whole number, it's a stretch. Okay, vertical shrink by 1/8 and reflect in the x-axis. Okay, so I'm going to do another little sketch here. And we'll see e to the x went like this, right? E to the negative x is going to go like this. It already is flipped across the y-axis, okay? That's what that negative does. But it starts out that way. So we'll go here. It looks like this. Goes down like almost touching. And then our second one reflects across the x-axis, so it's going to come down. And because it's a vertical shrink, that means it's squishing this way, smushing it downward. Okay, think about if you're smushing like a piece of gum or like a pancake. It smushes down, it gets wider outwards. So this one's going to look like this. Okay, it gets wider and fatter looking because it smushes downward. Okay, so it's not just flipping over. There is one on the practice like that, and if the two of them look a lot alike, but one of them is more smushed out. If there's no shrink, then it would just flip straight down and be exactly the same above and below. Okay, that's where I'm going to put my log transformations. And we didn't talk about log graphs last time. We're going to see them for the first time. But we did talk about the logs. Okay, a couple of things. The good thing about the logs on transformations is they're more what we're used to. Okay, the exponents, it was a little bit different because they didn't have any parentheses, which we are totally used to. But this one, right and left is minus and plus inside the parentheses. Okay, up and down is just normal on the end, plus or minus. Okay, reflection on the y-axis is inside the parentheses, just in front of the x. And in the x-axis is out front, like we're used to seeing. Right? Horizontal stretch or shrink and horizontal translation are both inside the parentheses. And just like before, if it's a whole number, you got to get the reciprocal, it becomes a shrink. A fraction, get the reciprocal, it becomes a stretch. And vertical will be a number out front. Okay? Stretch is a whole number, shrink is a fraction, you don't have to change it. Now, a couple of other things. You see these logs? Okay, we talked about logs last class. We didn't talk about ln last class. It is another kind of log, right? These are regular logs. ln is natural log. I don't know why it's not in L, okay? But the logs are the opposite, the inverse of exponents. We talked about that last class, right? ln is the opposite of the natural base e. Okay, that's why it's the same button on the calculator. You know how we've been pushing the ln button, that's the e. See how log is the 10 to the x? ln is e to the x. Okay, for what we're doing here, it doesn't matter. It's not going to change anything that you need to do today. Okay, we're going to learn more about it in the future. I just didn't want you to be like, what is that ln that we've been seeing? We've never seen that before. Right, so it's treated the same way as a log. You're worried about what's going on in the parentheses or the transformations. Don't worry about the difference between it. Again, we'll talk about that in the future. Okay, so number 5, we're going to just graph these next two. Number 5, f of x equals log x, and g of x equals log parentheses negative 1/2 x. One other thing I want to point out about logs is if you remember last class, we talked about logs the whole time, and they always had a little base down here, right? Floating down here. That was where our b was in the basement. But these don't have a b in the basement. Okay, that's a special, not a special, it's the most common type of log. It's called a common log. If there's nothing there, it's an understood that the log base 10. Okay, kind of like if you just have an x, you understand that there's a 1 in front of it, but you don't have to write it. This is the same thing. If you see a log, you don't have to type the 10 if it doesn't have a number there. It is 10. Okay, and remember we said last time you can't do logs in the calculator. Okay, well, we can do this time. If there's no base here, we can do that using this button. All right, and that's why the opposite is 10 to the x power, because it's log base 10. So our log button's right here. Our ln is right here, and it's the opposite of the e to the x power. Again, you don't really need to know all this yet. We haven't got to that part for what we're doing today. I just want to make sure that you weren't like, hey, last class there was a base, this time there's not, okay? It's understood to be 10, but you aren't going to have to be quizzed over that yet until we do more with it. So with logs,